Welcome to the Boston Echo Board's review course. Today we will be discussing another sample question from the review course. A STEM question will be shown on the screen, followed by 4 choices. You'll have about 30 seconds to make a choice of what you think is the correct answer, after which the correct choice will be highlighted, followed by a didactic discussion by the faculty regarding the concept that was presented in that question. Keep an eye on the clock because 30 seconds is all you got to make the choice. Have fun and good luck. The practice question will be based on this 3D image, which has color flow Doppler information in addition to the grayscale image. This will be shown for 30 seconds, followed by 4 choices for another 30 seconds, and you will be able to see the video at the same time. So this is a slightly complicated and a very hard question that relates to appreciation of three-dimensional anatomy of the left atrium, recognizing the mitral regurgitation jet, and appreciating its systolic nature. And at the same time, its impact on the pulmonary venous inflow waves is also expected to be appreciated to answer this question. So therefore, we'll be going over each of these choices, both with graphics and without graphics, to demonstrate how we reach the correct answer in this specific situation. So let us start with the video that was shown at the beginning of the case. And essentially the question related to the change in the pulse wave Doppler patterns based on what was being shown in this video. As you can see, this is the mitral valve. That's the left atrial appendage. This by definition is the Coumadin ridge, and this is the left upper pulmonary vein. Now if you look at on the video on the right side, you can see an eccentric regurgitation jet that is almost directed at the left upper pulmonary vein, with the blood being shown to spill over from the mitral valve into the left upper pulmonary vein. So that being said, it is obvious that this is a systolic phenomena, and whatever it will impact will be systolic in nature. So therefore, if you look at this deciphered and kind of labeled video graphic, you can see this is the mitral valve, left atrial appendage, left upper pulmonary vein. An eccentric mitral regurgitation jet is emptying into the left upper pulmonary vein. So whatever will be happening in the left upper pulmonary vein and during the systolic phase of the cardiac cycle. And as you can see, the normal pulmonary venous inflow pattern has an S wave, which is S1 and S2. S1 because of left atrial relaxation, S2 is the systolic wave, and D is the diastolic wave. And what happens in eccentric or severe mitral regurgitation that is directed at both pulmonary veins or one isolated pulmonary vein, this is the wave that is get impacted, and therefore this is the wave that shows reversal. So in this case, it would be the left upper pulmonary vein demonstrating reversal, and not the right upper pulmonary vein demonstrating D wave reversal. So that choice is wrong at 2 levels. Next comes the hardest concept, and that's this patient has Ena ratio which is less than 0.5 or 1.5. So mitral regurgitation is associated with an E dominant pattern, which means obviously there's more volume traversing the mitral valve from the left atrium into the ventricle, back into the left atrium. So it's a volume overload phenomena. So patients with mitral regurgitation have an E dominant wave pattern. And therefore in patients who have an A wave dominant pattern and have significant mitral regurgitation, severe mitral regurgitation is practically excluded. So the presence of an A wave dominant pattern, which means E over A ratio less than 0.5 or 1, which means E wave is smaller than A wave, mitral regurgitation is practically excluded, and that's as part of the ASE guidelines. So therefore, this patient would have, based on the video that we saw, a reversal of S wave in the left upper pulmonary vein.